stress A or stress B is equal to 0. So for our case, it is not. Okay, for our case, it's not. Okay, so for this situation, stress A and stress B are never going to be equal to 0. Okay, so the next thing we do, right, very standard protocol, we are going to find the center of circle. So we're going to find center of circle, which is over here. Okay, where's our center? So we're interested in the biggest diameter now, right? Because it's where we can find our stress A and stress B. So we look at center of circle. So center of circle for our case is also known as the stress average. So we know the distance from here to here. This is our stress average. So this will be equal to stress X plus by stress Y and the whole thing divided by 2. Okay, so stress X is equal to 33.953 times 10 to the power 3 plus by stress Y equal to 0, and then the whole thing will be equal divided by 2. Sorry, stress X is equal to 0. I do apologize. Okay, stress Y is not equal to 0. So this is equal to 0 plus, let me bring this down. So from here, we know our stress average, in fact, is going to be minus. I'm making too much mistake today. So 0 plus by minus, okay. So this will be equal to minus. Did I put a minus earlier? I forgot to put more minus earlier, okay. So this will be equal to minus 16.977 times 10 to the power 3 psi. Okay, so this is the only thing we know. So that's how. So to find stress A and stress B, right? So we know that to find stress A and stress B will be equal to the average stress, right, plus or minus by the radius, R. So over here is the radius of the circle, or R correspond to the radius of the circle. Right? So from here, we know we have this expression where stress A or stress B is equal to stress average plus R. And we're going to substitute this. Okay, I'm going to call this our equation number. Where's our equation number 1? Okay, so we're going to substitute. So equation number 1 is basically the criteria based comparing the yield strength with our what? With our stress state. So these are all our stress state. Stress A and stress B are principal stress state. This is our material property. That is given. Yes or no? We are given our material property to be equal to 42 times 10 to the power 3. Okay. So from here, we can write down. So we're going to substitute into equation number 1. Okay, so our equation number 1 is equal to stress average plus by radius squared minus by stress average plus by radius multiplied by stress average minus by radius. Then you have plus stress average minus by radius squared. Okay, and then the whole thing has to be less than your stress U squared. Okay, so when you expand the term, okay, so we're going to expand stress average squared plus by 2R stress average plus by R squared minus by stress average squared. So this one you can cancel off, then minus by R squared, right? And then finally you have plus by stress average squared minus 2r stress average plus by r squared. The whole thing has to be less than the u squared. Okay, so what we can get rid? So we can get rid of this these two over here. We can get rid of the r squared over here. We can get rid of these terms over here. Okay, so finally we are left with stress average squared, right, plus by,
Eugene, wouldn't the r squares add up?
yeah, I'm doing that now.
No, the one you canceled.
Oh yeah, it should not be. Thank you. Yeah, I should not cancel this one. So because minus become plus, right?
Yeah.
Thank you. So r squared plus by r squared plus by r squared. So it's plus by 3r squared. So this is equal to stress u squared. Okay. So now we are going to find, okay, so from here we are going to find tau max. Okay, we're going to find our tau max, which is equal to the radius. Yes or no? Right? Our tau max is equal to our radius. Okay, so now we're going to solve for r now, right? So we are going to write the expression where 3r squared is equal to stress u squared minus by stress average squared. So we have these values already, right? So we know that this will be equal, so the u will be 42 times 10 to the power 3 squared, and the stress average will be equal to minus 16.977 times 10 to the power 3 squared. Okay, so from here your r will be equal to, so 42 power of 3, 42 power of 3 squared minus by 16.977 power of 3 squared. Okay, divided by 2, and then square root the whole thing, so it's equal to 22.179 times 10 to the power 3 psi. So this will be equal to our tau max, right? Like what we say over here, right? So from here we know, right? So by what we know now is we have given that this expression over here, the shear xy is going to be what? Tc over j, right? So we know that tau max, okay, the maximum that this thing can go, right? So we know that txy max, right, is equal to what? Is equal to, okay, I think I'm skipping too much steps down here. Okay, I'm skipping too much steps. So how to relate this expression? How to relate? I do apologize. I should not skip so much. Shear xy to tau max. Okay. So now we go back to our mole circle. We go back to our mole circle now. Okay. So what we have found out, okay, we have identified what is this value now. Okay, so we have identified what is this value. Right. So we have shown that what is tau max equal to. So we found that tau max is equal to 22.179 times 10 to the power 3 psi. All right. So the next thing that we want to do now is we want to find, right? We want to identify over here what is our shear xy. Okay. We want to find what is this value. So from here we will know. So what we know now, we know the radius. So we know that this is our radius, right? Our radius, the distance from here to here, right? We know that this distance from here to here. So this corresponds to our radius is equal to what? Is equal to 22.179 times 10 to the power 3 psi, right? We know that, right? Then the next thing that we also know, right? We also are aware that the distance from here to here is the same as the distance from here to here, right? There's our stress average. So that is equal to 16.977, right? 16.977 times 10 to the power 3. So now we can easily identify what is our shear xy. Yes or no? Right? So we know that tau max, from here, we know that tau max, all right, tau max is equal, or we can directly write that shear xy squared is equal to, or shear xy, we use Pythagoras theorem, right? Is equal to square root of tau max squared minus by stress average squared. Okay, so over here we will have an expression where tau max is equal to 16.977. No, tau max is not 16, it's 22.179. Is it 20? Yep, 22.179 times 10 to the power 3 squared minus by the average stress, which is equal to 16.977. So minus 16.977 times 10 to the power 3 squared. Okay, so your shear xy, so 22.179 power 3 squared minus by 16.977 power 3 squared square root is equal to 14.272 times 10 to the power 3 psi. Okay, so finally we know how to relate that the shear xy is equal to TR over J, or TC over J. So it's just a matter of substituting now, right? So this will be equal to, so the shear xy is 14.272 times 10 to the power 3. We want to find what's our torque. So this C, this is pi over 2. This is pi over 2, and this is C to the power 4. You cancel this C to the power 3. So therefore, the torque will be equal to 14.272 times 10 to the power 3 multiplied by pi over 2, and then multiply by the radius, and you cube it. Okay, so this will be equal to 14.272 power 3 times by shift pi divided by 2 divided by times by 0.75 power 3 is equal to 9.458, right, times 10 to the power 3 pound inch. So this torque is based on von Mises. Okay, it's based on von Mises. So we're going to very quickly do the same thing, right? We're going to do the same thing to find from Tresca. Okay, so we're going to do, so we're going to now, any questions first? Okay, this is not difficult math. Okay, it's very easy math. Any questions, please? Okay, I don't hear anything at all. So the part that is very critical over here is you have to, and that you have to construct your mole circle first. Then to construct your mole circle, then you can easily visualize if stress A or stress B is equal to 0. If not, okay, you from here you apply von Mises criteria. Okay, you don't need to do this step in your exam. You can immediately come into this stage already. Yes or no? Right? So from here, you found that your torque based on von Mises is equal to 9.458. Okay, nothing difficult. Yes. Hello, someone try to say something? Anyone? No? Okay. So now we are going to do the same thing. Maybe we will do the same